So good morning to all and welcome you all for the 25th lecture. Okay, so today is a somehow special day for us because this is my 25th lecture for you people. Okay, so welcome you all for the 25th lecture on basic circuit theory. So where we are anyone? Unit 3. Okay, and we have been discussing theorem and we completed superposition and Thevenin and Norton's theorem. What is the next theorem? It's my favorite, What's the next theorem, anyone?
Maximum power transfer theorem.
So this time this is my maximum. Why is it so called maximum power transfer, right? Theorem. This time for AC circuit. Today's concepts, okay, are somehow interesting. Please listen it carefully. Okay. So as per your knowledge, okay, what is maximum power transfer theorem? For DC circuit, right? So for DC, you will have your source voltage. It may have some internal resistance, or otherwise this is your VTH, RTH, or otherwise this is VS, RS. Okay, and I am connecting some load here. Okay, take RL. When maximum power will be transferred to this load? Anyone? When maximum power will be transferred to the load?
When
When
RS equal to RL.
When
RL
RL equal
equal
to
to
RS.
RS. My question, which one is variable here? RL or RS? Which one is variable?
RL.
RL.
So which one is variable that Okay, you can understand that for RL is variable. Okay, you want to vary the variable. In such a way, I started the very first class. Okay, I proved maximum power transfer theorem with the help of numerical, but this time, okay, this relation, okay, with the help of numerical, we derived this, right? But this time, I want to derive this expression. Okay, so my conclusion here RL is variable. Okay, but one time gate question they have given, suppose take this is some 5 ohm, okay, and they have given this question, okay, for which value of, please take this question just for your knowledge, for which value of RS you will get maximum power across RL. Okay, the options are 1 ohm, option A, I'm writing here, just 1 ohm, option B 2 ohm, option C 3 ohm, option D 4 ohm. One time gate question. Okay, for easy people. For which value of RS you will get maximum power dissipation across RL? Okay, so note on the question. For which value of RL? For which value of RS? Okay, P max maximum power dissipation across RL. Read the question carefully. Anyone? Straight away, what we will choose? We are thinking, RL equal to RS, so we will choose option D, but that is wrong.
So
It's
1
this
ohm,
time.
sir.
Yeah, why 1 ohm? Yeah, very good answer is correct. 1 ohm. Why 1 ohm? Since this time my
அப்பதான்
RS is variable, okay, RS is variable. Uh, you know the power formula across RL, right? You know the power formula across RL. Power equal to take I squared RL formula, okay? So where I is Vs divided by, RS plus RL. This is my I squared RL, right? So now coming to this formula. Okay, if I want to get maximum power, so in order to get maximum power, the RS, okay, should be minimum as possible. Out of these four, which one is minimum? As he told, this 1 ohm. Okay, so what is the conclusion? You want to choose minimum value of RS. Okay, so choose minimum value of RS that will give maximum power dissipation across load. Okay, so this concept is very, very important. It's quite interesting. Okay, got my point. Okay, so what is the conclusion? Actually, as per maximum power transfer theorem, your RL should be variable. Okay, if you want to propose someone, okay, you want to adjust your resistance. Okay, they won't adjust their resistance. You want to adjust your resistance. Since here you are load, okay, you want to adjust your resistance. So RL should be variable, not RS. Suppose, but nowadays, நமக்காக பொண்ணு கூட அட்ஜஸ்ட் பண்ணுங்களா, அதுதான். அதை அட்ஜஸ்ட் பண்ணணும். அப்ப அந்த பொண்ணு என்ன பண்ணணும், நமக்காக ரொம்ப தரமட்டமா இறங்கி போகணும் இல்லையா? பிகாஸ் நம்ம கேரக்டர் ரொம்ப கேவலமா இருக்கும். இந்த கேஸ்ல என் ஒய்ஃபை கூட கன்சிடர் பண்ணலாம், சரியா? ஸோ they want to reduce their resistance as minimum as possible. So that is the practical thing. So now I want to derive this. Before deriving, I want to give, okay, what are all the possible cases in maximum power transfer theorem? So the one already we discussed, case 1. I want to give case 3. 3 cases. Case 1, see here, what is this guy? What about this? 3 keywords. One is called, what is this? Impedance. What do you mean by impedance? And what do you mean by resistance? And what do you mean by reactance? Anyone? All are, the unit is ohm, but what is the difference between impedance, resistance, reactance? Impedance denoted by Z, okay, resistance real part R, reactance imaginary part XL or XC. In terms of, can I take XC? So impedance means it will have both real and imaginary part, so R plus JX, right? So this is my impedance. Reactance only real part, reactance only imaginary part. Case 1 already what we discussed in our unit 2. Okay, suppose you may have both, what is this? Source resistance and this is load resistance, right? So case 1, source resistance, source also resistance, RS and load resistance. Both are resistance. At that time, what is the condition for maximum power transfer theorem? That RL equal to RS. Okay, be careful, not RS equal to RL. That already explained, right? So this is not the case. Okay, RL equal to RS. Yeah. So this already we discussed, but I want to derive this. N is not working. Give me some time. Yeah, it's working. So sorry. Yeah. So this is my case 1. Okay, source both are resistance. Case 2. Now coming to this unit 3, maximum power transfer theorem for AC circuit. For AC means, okay, you want to play with impedance. So now case 2. What is the case 2? Any guess? Source impedance. Both may be impedance, right? Source impedance and load impedance, right? Both are impedance. So source impedance means, can I take ZS? ZS means it will have real part as well as imaginary part. Take the real part as RS, imaginary part as XS. Load impedance, that ZL. So this time RL plus J times XL. Okay. If both are impedance, at that time, what is the condition for maximum power transfer across the load? Any guess at least? If both are resistance, ரெண்டுமே resistance இருந்துச்சுன்னா RL equal to RS. Okay, load resistance should be equal to source resistance. This time, any guess at least? What is the relation between ZL and ZS? Anyhow, have you heard this? அவங்க மேல்னா நம்ம யாரு? ஃபீமேல். நம்ம மேல்னா அவங்க யாரு? ஃபீமேல். ஓகே, இப்ப ZL ரெண்டும் மேட்ச் ஆகணும். எப்படி மேட்ச் ஆகும்? பட் திஸ் டைம் காம்ப்ளெக்ஸ், ரைட்? ஸோ வாட் யூ மீன் பை காம்ப்ளெக்ஸ்? ZS equal to RS plus JXS. This time, this is Paul 3, right? ZL. I want to match my impedance, okay, with the source. How? Any guess? So this time, if you will derive, you will get ZL equal to ZS conjugate. That is the condition for maximum power transfer theorem in AC circuit. Case 2. If both are impedance, okay, at that time, ZL. Okay, so what is my ZS conjugate? You know, R is this time minus JXS. Okay, if we will connect a load, okay, RS minus JXS, then maximum power will be transferred. Okay, so this is my case 2. And coming to case 3, what is my case 3? Any guess? This time source impedance, yeah, since AC circuit, source impedance, but or otherwise write like this: source impedance ZS. You know, this is RS plus JXS, but load is resistance. Okay, and load resistance RL. This time, what is the condition? Okay, this time only I am having real part in load. Okay, I don't have imaginary part. At that time, what is the condition? The condition is given by, you know, what is this? RL, I want to call it RL. I'm having only ZS. Take the magnitude. What is my magnitude? Square root of, you know, A squared plus B squared, where A equal to RS, B equal to XS. We are going to derive all this relation, but before deriving, just I want to give the final expression. It's very important. Sometimes they are asking derivation also, so there is no other way. We want to derive the derivation. Derivation is not a big thing, only 2 to 4 lines. Okay, you will get the final expression. So we will derive all the cases. So now these are all the cases. So I have given 3 cases. Case 1 already we discussed. Both are resistance. Case 2 both are impedance. Case 3 source impedance, load resistance. Is it possible to have source resistance, load impedance? Case 4, I mean, is it possible to have RS, source resistance, but load impedance? Load impedance means RL plus JXL. Is it possible to have source வந்து எனக்கு load, I mean, source வந்து எனக்கு வந்து resistance தான். But loadல வந்துட்டு can I connect resistance plus reactance? Can I connect impedance? Is it possible? At the time, can you match? It's not at all possible. Okay, you just relate this thing with the practical. Okay, but source impedance இருந்துச்சுன்னா resistance-ல, I mean, load resistance connect பண்ணலாம். That is possible. That is case 3. But in the reverse case is not possible. Okay, so we will discuss one by one. So now put the heading case 1. Case 1. Okay, simply I am writing RS and R. Okay, so let me draw the circuit diagram. So I am having my source Vs or Vth. It may have some internal resistance Rs or Rth. Now connect the load. Okay, RL. Since I'm going to play with the power, now what is the power across? What is the power dissipated by RL? What is the power formula? Take this current is some I. Okay, you know what is the power across this power dissipated by load resistance? Power formula, I want to take I squared RL formula. What is the formula for I? Where I equal to, you know, Vs square divided by, sorry, I equal to, you know, Vs divided by Rs plus RL. So this one square times RL. So can I write the power formula Vs square divided by Rs plus RL the whole square times RL? Any doubt in this? What is the power? Okay, dissipated by load. Okay, so piece of RL equal to, you know, this time I have taken I squared R formula. So where I equal to V by R, V is Vs, Rs, you know, R is Rs, RL both are considered in series. So that's what I have given Rs plus RL. So the whole square times RL. Any doubt till now? Any doubt till now? So finally, people, I want to know one thing from you. You might have found, okay, maxima and minima in your mathematics, okay, anywhere. What is the when you will get maximum value? What is the condition for that? Here I want to get maximum power, right? So when you will get maximum, what is the condition for maxima? I will give you one clue. What is your understanding, okay, from differentiation, or what is differentiation? Practically, what is your understanding? Differentiation na enna? Why are we doing differentiation? Integration, nothing but addition, right? Cumulative value it will give. So what do you mean by differentiation? Any guess? What is your practical understanding about differentiation?
Sir, finding the rate of change
Finding the rate
or
of
slope.
change. You got the keyword slope. Then what is the need for finding slope? Okay, when you will get maximum value, it may be power or it may be voltage, but in general, when you will get maximum, if there are no changes in the slope, right? If there are slope is zero. So slope is zero means what do you mean by slope? Okay, so differentiation of this power, okay, with respect to who is your variable? Always, okay, your load resistance RL is variable, right? Don't change this condition. So differentiation of this power with respect to load, with respect to variable, that will give you zero for maximum power transfer, right? So that is the condition. So the practical interpretation of differentiation and all. Okay, I don't want to explain in a detailed manner, but this is the condition for maxima. So now, what is this condition? What it says? D by dRL of, okay, power dissipated by load. It is given by Vs squared RL divided by Rs plus RL the whole squared, which is equals 0, right? Can you remember this formula? Differentiation, okay, of U by V. Both are variable. What is the formula? Can you remember this? This is, okay, first what you will do?
VDU minus UV.
Sorry.
VDU
Yeah, you will
minus
keep
UV.
the denominator as it is. Then first you want to differentiate numerator. Then you want to keep numerator as it is. Then differentiate denominator and divide by denominator squared, right? Can you apply this formula here? So first what I will do, my denominator Rs plus RL squared, okay, actually V squared, right? This squared. So first you want to keep denominator as it is. So I am keeping denominator as it is. And what is the differentiation of Vs squared RL with respect to RL? It is Vs squared minus, keep this numerator as it is. Then this time, okay, differentiate this RS squared plus RL the whole square with respect to RL. So what you will get? This 2 times, RS plus RL into where RS is constant. Differentiation of RL with respect to RL will give you 1. This equals 0. Any doubt? Simple mathematics. Okay, this simple formula. If you know this formula already n number of times, okay, you might have come across this. Okay, so simply I applied that formula. Any doubt? Any doubt in this equation? Hope so you are enjoying.
No, sir.
So now bring this term, okay, to the right hand side. It becomes 0. So remaining, what is this? RS squared. Take Vs squared as common. So here I took Vs squared as common. So remaining I am having this guy Rs plus RL the whole square. Here also I took Vs squared as common. So remaining I am having 2 times RL times Rs plus RL into 0 plus 1 will give you 1. which equals 0. Okay, I moved this term, okay, to the, or if you want to write here, please write 0 times Rs plus RL, the whole square times the whole square becomes 0. Okay, now move this Vs squared also to the right hand side. So what else remaining? You will end up with, what is this formula? A plus B the whole squared formula, that you know. Okay, A squared plus B squared plus 2 times AB. Okay, and what about this one? Just to expand this, you will get 2 times Rs RL minus 2 times RL squared equals 0. Okay, so now see, this is 2 times Rs RL, this is minus 2 times Rs RL. So remaining, this is my RL squared, this is minus 2 RL squared. So you will get Rs squared minus RL squared equals 0. I'm looking for RL. So what is my RL squared? This is RS squared. Therefore, RL equals RS. I hope so. You enjoyed my first derivation, right? Fourth unit நிறைய derivation இருக்கு. You will enjoy. Yes, sir. I love to derive. என்னுடைய ஈஸி சப்ஜெக்ட் மோஸ்ட் ப்ராப்ளி எல்லாமே ஃபுல் அண்ட் ஃபுல் டெரிவேஷன் நியூமரிக்கல்ஸ் தான் இருக்கும். ஐ டோன்ட் நோ ஹவு டு டீச் தியரி என்றால் அது நமக்கு வராது. நமக்கு இந்த அதிகம் பேசுறதெல்லாம் பிடிக்காது. Okay, just I want to play with numbers, I want to play with derivation, I want to play with concept. That's it. என்னோட ஈஸி சப்ஜெக்ட் ஃபுல் அண்ட் ஃபுல் எல்லாமே 90% அனாலிட்டிக்கல் தான் எடுப்பேன். இது வரைக்கும் நான் தியரி எடுத்ததில்லை, எடுத்த ரொம்ப கேவலமா இருக்கும். ஓகே, so I hope so this you enjoyed this concept, right? So this is just for your knowledge. So RL equal to RS. So now take this, we will go to the next case. Okay, I will forward my material in that this derivation will be given, you don't worry. So now can I move to the next case? Case 2, it's quite interesting and it is important. Okay, try to understand this concept clearly. What is this? ZS, source impedance, and ZL, load impedance. Can you draw the equivalent circuit diagram this time? So this time you will connect your AC, right? This is your VS or VTH, but this time load, right? So this is my ZS RS plus JXS, right? Sorry, impedance, source impedance, and take this is my ZS, ZL, RL plus J into XL. Okay, so this is my case, and as usual assume this is my current. Okay, but this time in case 2 you are having 3 subdivision again. That is the beauty. Take case 2A, case 2B, case 2C. Okay, what is case 2A? Any guess? See, load is variable. Yeah, what is this load? My ZL. This is my ZL. Yeah, ZL should be variable. Yeah, accept that it should be variable. But here ZL equal to ZL equal to RL plus JXL, right? So ZL equal to RL plus JXL. Okay, so sometime my RL alone variable, that there may be a chance. Okay, or some other time my XL alone variable. Okay, sometime both may be variable. That is my ZL actually. Okay, so both RL XL are variable. Okay, so this is case 2A, 2B, 2C. So let me write in terms of statement. So if RL alone, yeah, my load is impedance, right? It consists of real and imaginary part. But out of real and imaginary part, my real part alone variable. If R alone is variable, at that time, what is the condition for maximum power transfer theorem? Then if XL alone variable, RL alone variable, not is. If XL alone variable, okay, here if both are variable, means ZL is variable. Okay, so if RL alone variable, what is the condition? If XL alone variable, what is the condition? Then combination of these two effect will give you what is R. For this only straight away I have given this ZL equal ZS conjugate, right? But how to achieve this? Okay, how to get this expression? That's quite interesting. Now listen me carefully. So put the heading case 2A. Okay, if RL alone variable. Here, what is the power dissipation formula? Power dissipated by load. Here also take the same formula, I squared RL. Here, what is the formula for I? I equal to V by R, where V is Vs divided by R is, total resistance, right? Rs plus JXS plus RL plus JXL. What about this formula? Times. Okay, what about this is my I? So I squared times RL. So this is my Vs squared. Okay, divided by Rs plus RL plus J times. Can I write XS plus XL? Okay, the whole squared times RL. What is the magnitude of A plus JB? How will you find A plus JB squared? You will take the magnitude, nothing but square root of A squared plus B squared, the whole squared will give you actually A squared plus B squared, right? Can I write like this? Any doubt? So now here also take the magnitude. Tell me.
சார் இங்க ஆர்எல் ஏன் சார் போறோம்? ஐ ஸ்கொயர் ஆர்எல் பதிலா நம்ம டோட்டல் ரெசிஸ்டன்ஸ் தானே சார் இருக்கும்.
That's the point. இப்போ இந்த டவுட் வரும். இது ரொம்ப இதுக்கப்புறம் இன்னொரு டவுட்டும் வரும். டிஃபரன்ஷியேட் பண்றப்ப ஆர்எல் வச்சு தான் டிஃபரன்ஷியேட் பண்ணுவேன். ஓகே, அது ஏன்னு எக்ஸ்பிளைன் பண்றேன். அதுதான் ஃபர்ஸ்ட் ஸ்டெப்லயே சொன்னேன், டோன்ட் சேஞ்ச் த ஃபார்முலா அப்படின்னு. See, always, okay, you want to take this maximum power dissipation across the load. Okay, load you want to consider as resistance alone. In case of AC also, that I will explain. Okay, after deriving all the relation. But your thinking is correct. I will give the definite. I will give the concept. Okay, later. Now just listen. So here also the formula is same. Irrespective of AC or DC, you want to go with I squared RL. Okay, ஏன் அப்படின்னா actually you want to play with average power அப்படின்னு ஒரு கான்செப்ட் இருக்கு. Okay, since AC circuit, you are having both magnitude, okay, as well as ரெண்டாவது என்னதுமா இருக்கும், மேக்னிடியூட் இருக்கும், அப்புறம் ஆங்கிள் இருக்கும், ரைட்? ஸோ பிகாஸ் ஆஃப் திஸ் ஆங்கிள் என்ன ஆகும்னா காஸ் தீட்டா வில் கம் இன் டு பிக்சர். அதனால இந்த ஃபார்முலாவே இப்போ வேரி ஆகும். ஸோ அந்த அளவுக்கு டெப்தா போக வேண்டாம். ஸ்ட்ரெயிட் அவே ஐ வில் கிவ் த ரிலேஷன், ஐ வில் கிவ் த ஃபார்முலா, ஜஸ்ட் ஓகே, கீப் இட் இன் யுவர் மைண்ட். ஸோ ஹியர் ஆல்சோ டோன்ட் சேஞ்ச் த ஃபார்முலா. த ஃபார்முலா ஐ ஸ்கொயர்ட் RL. ஓகே, கீப் அஸ் இட் இஸ். ரெண்டு இடத்துல கான்செப்ட் இடிக்கும். தட் ஐ வில், there is no other way that you want to bear with me. Okay, so VS squared, I will explain. So VS squared RL. So now what is the magnitude of this one? A squared plus B squared. Okay, where A equal to RS plus RL plus B squared, that B equal to XS plus XL the whole square. Okay. That I will explain. Why RL alone? Why not ZL? That's your question. Yeah. Spend some time with me. So till now, any doubt? So this is the power dissipation across the load. This time also consider load as resistance only. Okay. So I squared RL. But this time for I you want to consider impedance, right? So I equal to V by R, where V is Vs divided by Rs plus JXS plus RL plus JXL. So you will get this formula. B times this is my load. So when you will get maximum power dissipation, as I told earlier, this differentiation of this one with respect to again RL. Okay, because this time my RL is variable, not only because of RL is variable, in general for any maximum power transfer theorem, you want to take RL is variable. It may be XL or it may be ZL or it may be RL. Okay, but you want to go with only RL. That is a generalist thing. Okay, otherwise it will confuse you because you want to play with that cos theta and because of angle. அதில் வந்துட்டு அந்த நம்ம இண்டக்டர் கெப்பாசிட்டர்னாவும் இருக்குதா அந்த ஃபேஸ் ஆங்கிள் டிஃப்ரென்ஸ் கண்டுபிடிச்சிருப்போம் கரண்ட் லேக்ஸ் வோல்டேஜ் லேக்ஸ் அதெல்லாம் கொஞ்சம் டீப்பாக பேசணும் பட் தட் இஸ் நாட் ரிக்வயர்ட் ஸோ ஜென்ரலாக என்ன பண்ணிக்க ஆல்வேஸ் கோ வித் ஆர்எல் இட்ஸ் பெஸ்ட் ப்ராக்டிஸ் ஓகே ஸோ நவ் வாட் இஸ் த டிஃபரன்சியேஷன் ஆஃப் power dissipation across RL with respect to RL is 0, right? So now D with respect to DRL of this one. Vs squared RL divided by Rs plus RL the whole squared plus Xs plus XL the whole squared, okay, equals 0. So here also same differentiation. So can I do that? So V squared, okay, U by V, that you know, V squared. So Xs plus XL the whole squared, right? You want to keep new denominator as it is. So Rs plus RL squared, Xs plus XL squared times what is the differentiation of Vs squared RL with respect to RL? It will give you Vs squared. Then minus, you want to keep numerator as it is. So Vs squared RL. This time what is the differentiation of this one with respect to RL? Okay, since RL is variable. So with respect to RL, again it is give 2 times, Rs plus RL. So remaining all are 0, right? So this is my equals to 0. Any doubt in this? Or do I want to repeat the step? How to remember the final expression? Since I am playing with ZS, this is Rs plus J into Xs. ZL, this is RL plus J into XL. My RL is variable, right? So if you will derive the formula, you will get RL equals, take the magnitude of remaining thing. Take the magnitude of remaining thing. Remaining RS, so square root of RS square, magnitude, right? So square root of A squared plus B squared, where A is, this is my A, and this will give you B. So Xs plus XL the whole square. Okay, so this is the very important relation. So if you will derive this, you will get this one. Okay, we'll see whether we will get that or not. So now bring this term to the right hand side becomes 0. So what else remaining? This is Rs plus RL the whole square. What is the formula? A squared plus B squared plus 2AB. Okay, plus keep this one as it is. Don't change. Okay. And take V squared as common. Take V squared as common and bring this V squared also to the right hand side. You will get 0. So remaining. What else remaining? Xs plus XL square. Okay. Minus here I am having. What about this one? 2 times. Okay. Rs RL minus 2 times Rs squared equals 0. Any doubt? ஒரு 2-3 ஸ்டெப் ஒரே ஸ்டெப்ல போட்டிருக்கேன். Just understand by yourself. Okay. Can you understand, or do you want to write all the steps? I moved this, okay. I repeat, I moved this term to the right hand side becomes 0, and I took Vs squared as common, okay. Moved this Vs squared also to the right hand side becomes 0. So remaining என்ன இருக்கும்? Only 3 terms இருக்கும். 1, 2, 3, okay. I didn't change equation number 2. The 2 அப்படியே வச்சிருக்கிறேன். xs plus xl square. நம்பர் 1 என்ன பண்ணியிருக்கேன்? a plus b the whole square formula யூஸ் பண்ணியிருக்கேன். நம்பர் 3 just expand பண்ணியிருக்கேன். That's it. Got my point? Yeah. So now this is 2 times rs rl. This is 2 times rl plus rl. And this is rl square. This is minus 2 times rl square. So what is my final expression? rs square minus rl square plus xs plus xl the whole square equals 0. I'm looking for rl square, which equals rs plus xs plus xl the whole square. Therefore, what is my rl? Square root of rs plus xl plus xs the whole square. R squared, right? R squared plus இதுதான் இங்க சொன்னேன். How to remember this final expression is very important, okay. Since both my load and source are impedance, load is variable, here RL alone variable. So except RL, remaining I am having RS, real part, the whole square. Imaginary part, XS plus XL, the whole square, okay. So it's very easy to remember the final expression, okay, when RL alone is variable. Got my point? What's the time? 11:10. I can complete only derivation by today's class. Actually, I want to solve problems, but it is not possible, I think so. You got my point? You just sit and derive, okay? Very simple derivation. Okay. Case 2a over, right? Coming to case 2b. If XL alone variable, okay, and you know the formula for power dissipation across load, same formula, don't change it, okay. I squared RL, where I equal to, you know, because of PS square divided by, this is RS plus RL the whole squared, okay, plus XS plus XL the whole squared, right, times RL. So this is the power dissipation across load. Same equation I took. Okay, this equation. Okay, yeah, this one. This we derive, right? V square divided by the same. But this time also, you know, even though my XL is variable, okay, even though my XL is variable, but you want to differentiate this power, okay, across the load, the power dissipated load with respect to RL only. Isn't it? This time with respect to RL or XL? Any guess? Here confusion comes, okay. Here you want to be clear. So this time actually, who is variable? XL, not RL, okay. Clearly I have given the heading. Case 2b, if XL alone variable, so this time you want to differentiate with respect to XL. Okay, this is one thing. Point number two. Point number one, the formula, okay, for power dissipation across the load, always you want to go with RL. Okay, so point number one, power dissipation across RL, power dissipation across RL, this you want to remember. Okay, point number two, whoever is variable and you want to differentiate with respect to that variable. Okay, if RL alone variable, then differentiation with respect to RL. Okay, if XL is variable, then with respect to XL. The next case with the difference with respect to impedance ZL. Okay, so here if you will differentiate with respect to XL, since XL is variable, so you will get 0. So d by dxl of which one? Vs squared RL divided by Rs plus RL the squared plus XL squared, okay, equals 0. Now can you differentiate with respect to XL this time? So it's very simple. V squared, right? So Rs plus RL squared plus XL squared, the whole squared. And you want to keep denominator as it is. My denominator, RL plus RL squared. Okay, XS plus XL squared times what is the differentiation of VS squared RL with respect to XL? Anyone? Differentiation of VS squared RL with respect to XL? Then you want to keep VS squared RL as it is. Guys, are you with me? Differentiation of VS squared RL with respect to XL. What's the value? இருக்கீங்களா இல்லையாடா?
Yes, sir.
Differentiation of V squared RL with respect to XL.
0, sir.
Thank you. இது கேட்குற எவ்வளோ நேரம்? 0. Then you want to keep V squared RL as it is. Then differentiation of this guy. RS squared plus RL squared plus XS plus XL the whole square with respect to XL. So this time you will get 2 times XS plus XL. Okay, equals 0. Now this is my 0, right? அப்போ இது என்ன ஆயிரும்? ஃபுல்லாக 0 ஆயிரும். And bring this term to the right hand side, you will get 0. So remaining என்ன இருக்கு? Minus VS squared RL 2 times XS plus XL equals 0. Okay, now bring this term to the right hand side, you will get 0. So you will end up with XS plus XL equal to 0. That is another interesting relation. Okay, XL equal to minus of XS. Okay, here I conclude, source impedance, load impedance, source impedance Rs plus jXS, load impedance RL plus jXL. Okay, RL plus jXL. If RL alone variable at that time, that is my case 2a, RL is given by the magnitude of remaining things, RS squared plus XL plus XS the whole squared. Coming to case 2b, okay, this time case 2b, if XL alone variable, at that time XL is given by XL equal to minus XS. Okay, what do you mean by minus? Here inductor means capacitor, that's it. Okay, that's the meaning of minus, that you know, right? So this is the conclusion of case 2b. Coming to case 2c, it's very important. Case 2c, if both are variable, நான் என்னன்னா அந்த டெரிவேஷன் கூட என்னோட ஓன் டெரிவேஷன். ஓகே, புக்ல வந்துட்டு பெரிய பெரிய டெரிவேஷனா இருக்கும். இட் இஸ் நாட் அண்டர்ஸ்டுட் பை யூ பீப்புள் அண்ட் ஆல்சோ இட் இஸ் நாட் ரெக்கார்ட் ஃபார் யூ பீப்புள். ஸோ என்னோட வே ஆஃப் அண்டர்ஸ்டாண்டிங், ஓகே, அதை வச்சு நான் டெரைவ் பண்ணது. ஆனால் அந்த ரெண்டு கான்செப்ட் கொஞ்சம் லாஜிக் மிஸ் ஆகும். அதையுமே எக்ஸ்பிளைன் பண்ணலாம், பட் ஃபார் தட் ஐ வாண்ட் டு கோ வித் யூனோ all the required equations. Again, it is complicating, so I don't want to go in that manner. So now, if both are variable, you know, it's very important. If RL is variable, okay, if RL is variable, at the time, what is the formula? RL equal to square root of RS squared plus XL plus XL the whole squared. If you know XL is variable, at that time XL equal to minus XS, right? Take equation number 1, equation number 2. Now substitute equation number 2 in 1. What you are getting? Substitute equation number 2 in 1. Substitute equation number 2 in 1. Equation 1, RL equal to RS squared plus XL plus XS the whole squared, which implies RS squared plus XL equal to minus XS plus XS the whole square. Okay, so this becomes 0. So you will end up with RS squared equal to RS. So RL equal to RS. Okay, XL equal to minus XS. Now combine these two. So combination effect. Okay, what is my ZL? You know, ZL in general, RL plus JXL, where RL equal to RS plus J, okay, XL equal to minus XS, okay. I used these two, RL equal to RS, okay, and ZL equal to minus XS. So now, what is this? RS minus JXS. So what is this? RS plus JXS conjugate, right? So what is this? ZS conjugate. ZL equals ZS conjugate. Very important derivation, okay, for EC people. And for you, this is just for your understanding. கன்க்ளூஷன் தெரிஞ்சா போதும். ஓகே, இந்த டெரிவேஷன் தே வோன்ட் ஆஸ்க், டோன்ட் வெரி, பட் இருந்தாலும் தெரிஞ்சுக்கணும் இல்லையா, எப்படி வந்துச்சுன்னு தெரியல, அதுக்காக டெரைவ் பண்ணிட்டு இருக்கேன். அண்ட் இட்ஸ் மை ஓன் ஃபைண்டிங், ஸோ ஐ வாண்ட் டு லெட் யூ நோ. தட்ஸ் இட். See, this combination effect and all, you know, I took that much time to get all the relation. Okay, புக்ல வந்துட்டு ஒரு பெரிய டெரிவேஷனா இருக்கும், அது என்னன்னே புரியாது. But this is the way. This is my understanding. So we completed case 2. Okay. Case 3, it's very simple. Let me complete that also. Case 3, source impedance and load resistance. Okay. So what is case 2A and what is case 3? Any idea? Case 2A and case 3. Case 2A, what it says? Case 2A. Case 2A, RL alone variable, right? Case 2A, RL alone variable. Now put XL equal to 0 in case 2A, you will get case 3. I write the statement, try to understand. Case 2A that you know, case 2A, okay. Here you know ZS, source impedance, load impedance, okay. Source RS plus JXS, load RL plus JXL. Got my point? But here RL alone variable. If RL alone variable, you know the result RL equal to square root of this RS squared plus XS plus XL the whole square. Now what is case 3? See, same case. ZS, yeah, I'm having ZS, but I'm having only RS, RL. Therefore, what happened to XL? So put XL equal to 0 in case 2A. Okay, that is equal to case 3. Got my point? So now, therefore, what is my load here? RL equal to, from case 2A, what is my RL? From case 2A, this is my RL. I am writing here RL equal to square root of R squared plus XS plus XL the whole square. Here put, XL equal to 0. So it becomes RS squared plus XS squared. What is this R squared plus XS squared? Since my jet is, RS plus JXS. What is the magnitude of jet is? Square root of A squared plus B squared. So what is this? Magnitude of, that is the conclusion. Now I will conclude everything. This tabular column is for you people. Okay. So now listen me carefully. Total
சார் அந்த காம்பினேஷன் எஃபெக்ட் மட்டும் கொஞ்சம்
combination effect. Yeah. புரிஞ்சிருக்காதுன்னு நினைக்கிறேன் யாருக்குமே. ஏன்னா இது ரொம்ப மைனூட்டா கவனிச்சா மட்டும்தான் புரியும். ஓகே. Case 2A, RL is variable. This is my result. Case 2B, XL is variable. This is my result. I am combining these two. Okay. For that, what I am going to do? I am going to substitute equation number 2 in 1. This is my equation number 2. Substitute equation number 2 in 1. We will end up with this another beauty relation, RL equal to RS. Now this combination effect, okay. I know RL, I know XL. I want to find what is ZL, that is R plus JXL. Okay, where RL equal to RS. I am using green color. RL equal to RS. Okay, so RL equal to RS. XL equal to minus XS. So XL equal to minus XS. So it will give RS minus JXS. What is RS minus JXS? Conjugate of RS plus JXS. What is RS plus JXS? That is my ZS. So this can be written ZX conjugate. So this is the conclusion. It's very important. Akshay Kumar, okay.
சார் புரிஞ்சுச்சு சார்.
Okay, thank you. So now the conclusion is very, very important for you people. Based on this conclusion, we are going to. இதுக்கப்புறம் இன்னும் ப்ராப்ளம் வேற இருக்கு. சொல்லுமா.
ZS ஸ்கொயரா இல்ல வெறும் ZS சார்? I mean magnitude of ZS மட்டுமா இல்ல ZS square?
That is sorry. That is magnitude, not square. Magnitude, square root of A squared plus B squared, right? Yeah, very good. That is square, not square, magnitude. So here I conclude everything. First I conclude பண்ணா புரிஞ்சிருக்காது, பட் இப்போ புரியும் நம்புறேன். Okay, here I am writing the case. Here I am writing the condition. Okay, case means case 1. Okay, it's very important. What is the case 1? Source resistance and load resistance. Now you guys please speak. Okay, what is the condition for maximum power transfer theory? If both source and load are resistance, that load resistance equals source resistance. Okay, at that time, what is the formula to calculate maximum power? That you go with any formula, either V times I or I squared R or V squared by R. In the formula pola. Okay, but now coming to case 2, can you write by yourself? And case 3, case 2. What is case 2? It's very important. What is case 2? ZS, source impedance and load impedance. What is the condition? At least write the final conclusion. If both are impedance, so what is my ZL? It is equals ZS conjugate. Okay, we will solve one problem, then you can understand. Coming to case 3, source resistance, but this time load source impedance, but this time load resistance. Now what is my RL? Nothing but magnitude of impedance, source impedance. Okay. இந்த ரெண்டுலையும் பவர் ஃபார்முலா ஸ்ட்ரெயிட்வே ஐ எம் கோயிங் டு ரைட் த பவர் ஃபார்முலா சின்ஸ் இதுல வந்து இந்த ஃபேஸர் டயக்ராம் அந்த ஆங்கிள்லாம் இன்வால்வ் ஆகிறதால ஸ்ட்ரெயிட்வே ஐ வில் கிவ் யூ த ஃபார்முலா. ஹவு திஸ் ஃபார்முலா கேம் தட் ஆல்சோ வி கேன் டெரைவ், பட் தட் இஸ் நாட் ரெக்வயர்ட் ஃபார் யூ பீப்புள். ஸோ ப்ளீஸ் ஸ்ட்ரெயிட்வே டேக் த ஃபார்முலா. Here, case 2, the formula is, you want to calculate VTH divided by 8 times RTH. Okay, please keep it in mind where RTH is real part of, okay, ZTH. Okay, understand what it says. We will solve problems. Here the formula is, for case 3, the formula is half times, you want to find the magnitude of I squared R formula. Here it is half times. You want to take the load RL. Okay. Where RL, for case 3, what is RL? RL is nothing but magnitude of source. Okay. Take this in the form, in the tabular column derive பண்றது தான் இவ்வளவு கஷ்டப்பட்டிருக்கேன். Based on this, we will solve the problems. Then you can understand in a better way, I think so. Just to remember this tabular column, it is sufficient.
சார் அங்கே மறுபடியும் RL equal to ZS ஸ்கொயரா சார்?
சாரிம்மா, ZS தாம்மா, கோபப்படாம. Simply I am writing. Okay, now take this problem. Just to understand, okay, the above tabular column. நீங்களாம் ஹோம்ஒர்க் ப்ராப்ளம் சொல்லுவாங்கல்ல, நான் எப்படி சொல்லுவேன் அப்படின்னா TYU ப்ராப்ளம்னு சொல்லுவேன். Have you told this? TY, I never say homework problem. I will use the word TYE. You know what do you mean by TYE? Test your understanding. So I want to test your understanding. Okay. So now anyone, what is the value for ZL for maximum power dissipation across it? Compute ZL for maximum power dissipation across it. What's the value for ZL? Anyone? And obviously this is my ZS. Okay. ZL, anyone? நீ தெரிஞ்சுக்கிட்டு அமைதியா இருக்கியா, தெரியாம இருக்கியான்னு புரியல, சொல்லு பார்க்கலாம் ஆன்சர். இட்ஸ் வெரி சிம்பிள்.
சார் 3 - 4 சார்.
வெரி குட், அவ்வளவுதான். இதுதான் எவ்வளவு கஷ்டப்பட்டு. This is case 2. Okay, this is ZS, source impedance, ZL, load impedance. If both are impedance, then my ZL equal to ZS conjugate equals 3 plus 4J conjugate, that 3 minus 4J. So if you will connect 3 minus 4J here in the load, then you will get maximum power transfer theorem. At the time the power is given by, straight away please use the formula that tomorrow we will solve. VTH divided by 8 times RTH. Okay. Now take another problem. Example 2. Take the same problem, but this time instead of impedance, I want to connect resistance. Take the same problem. Compute RL for maximum power dissipation across it. Yeah, anyone?
5 ohms.
Yeah,
5 ohms.
very good. So RL equal case 3, source impedance, load resistance. So source impedance, load resistance means your RL equals, magnitude of source witness, that is not squared ma manichire. So magnitude of, or otherwise do one thing. Let me write one more step. So magnitude of, what is this? 3 plus 4j. So this is nothing but 3 squared plus 4 squared will give you 5 ohms. This is what's the time, ma? Yeah.
11:35, sir.
So time up, right? We will solve problems tomorrow, and I want to solve one more problem. Vignesh,
Yes, sir.
answer பண்ணு பார்க்கலாம். Find ZL for maximum power.
Sir, 8 plus 5J.
Okay. My girl side யாராவது இருக்கியா? Yes, I want to know whether I reached you people or not. Girl side யாருமா இருக்கா? First name யார் வரா? யாருமே இல்லையா girl side? இல்லடா girl side இல்லையா? எனக்கும் தெரியலையா? மரியா சொல்லுமா. For the next problem. Suppose if I will connect, 12, 24. Yeah. Maria, are you there? Maria Kiran Joshua. இருக்கீங்களா? இல்லையா? Very good. Come on, anyone? Can you help me? This time, what is your RL for maximum power?
13 ohms, sir.
Yeah, very good. You got my point, right?
Yes,
Got the
sir.
conclusion, right? I hope so. Today's class is understood, right? And we will solve some more problem. Okay, and we will find the power. What is the maximum power also? Okay. Since we found only resistance, impedance, right? Suppose if we will connect 8 plus 5j, at the time, what is our P max? What is the maximum power dissipation across it? And here also. Okay, that with the help of straightaway formula. So no need of derivation and all. Okay, just for your reference only I derived. The final conclusion is very important. I repeat that this already we discussed. Okay, case 1. Now coming to case 2, case 3. Both are impedance complex conjugate. Source impedance, load resistance, magnitude of source. That's it. Mod of ZS, square root of a squared plus b squared, where a equal to rs, b equal to xs. So that's it for today's class. Problem we will solve it by, I think so, last day, third hour, right? So thank you guys. So thanks for your
Thank you,
attention.
sir.
So those who are having doubts, you can stay. Others you may leave. Thank you.